Yes, this is of the Unit 5, which are going to discuss about future trends, privacy, and managerial considerations in analytics. Analytics involves the discovery, interpretation, and communication of a significant patterns in data. That is, it transforms the raw data into actionable insights, helping organizations make informed decisions that can enhance performance and drive growth. Simple, we can say like analytics is essential in various domains, including business, healthcare, finance, and marketing, where it aids in understanding trends, predicting outcomes, and optimizing processes. We also have a type of analytics that we have discussed in previous video, like of descriptive analytics, diagnostic analytics, predictive, prescriptive. So let's move on to the next slide. That is a future trends in analytics. Analytics is rapidly evolving with the technological advances. So the those key trends, these domains play a vital role by using those technology analytics. First domain is artificial intelligence and machine learning. AI, that is nothing but the artificial intelligence, is a field of science concerned with building computers and machines that can reason, learn, and act in such a way that would normally require human intelligence, or that involves data whose scale exceeds what humans can analyze. That is a given here of automated analytics and predictive insights, and prescriptive analytics to recommend actions. And next domain, the technology plays a vital role in real time and streaming analytics. That is a key approaches in this domain that enable organizations to derive value from the data as it is generated, or streaming analytics and real-time analytics. While both terms are often used interchangeably, real-time analytics, it provides the ability to extract useful insights quickly from massive data sets. And coming to the next domain, which is NLP, natural language processing and conversational analytics. So, while we talk about this natural language processing, it's a subfield of a computer science and also artificial intelligence that focuses on the interaction between computers and human language. It enables machines to understand, interpret, and generate human language in a way that is both meaningful and useful. So, the key principle when it comes to natural language processing, that is it combines computational things, that is which involves rule based modeling of human language with statistical modeling, machine learning techniques, and also deep learning. So these type of combinations allow computers to analyze and process text or voice data, that is grasping their full meaning, including the speakers or writers intentions. While using in the technique, the NLP encompasses a wide array of techniques aimed at enabling computers to process and understand human language. So the key techniques which comes under this NLP, you can say normally text processing, which is nothing, and also pre-processing. Uh, the methods which we use under this process are tokenization, stemming, removal, and text normalization. Likewise, we can say for it is used for syntax and parsing, semantic analysis, information extraction, text classification, language generation, and also you can say speech recognition processing, that is a speech processing has been processed, that is from text to speech synthesis. So all these techniques or comes under the NLP technique. And next part of the domain that the technology plays a vital role in augmented analysis. When it comes to augmented analysis, that is it is also integrates AI, machine learning, and natural language processing into data analytics, that is to enhance the decision making process. It simplifies normally the complex data task, making analytics accessible to non-technical users while improving efficiency and accuracy. So organizations normally use this type of augmented analytics in order to automate data preparation by the methods which I'm going to say here. There is a cleaning, organizing, and aggregating data from multiple sources. So these usually reduce the manual effort and ensures the data quality. So these type of algorithms can detect and format a information into your useful insights. So next domain is a cloud based and edge analytics. That is I have given here with a scalability with cloud platforms and faster insights from edge devices. So edge analytics on the other hand is a specialized form of a data analytics that occurs directly at the source of a data generation, such as IoT devices, sensors, or edge nodes. Like instead of sending the all the raw data to your central system for processing, edge analytics analyzes the data locally in real time. So this approach really reduces the latency and minimizes the bandwidth usage and enables immediate decision making. And next we are going to talk about data democratization. It refers enabling employees across all levels of an organization to access and utilize data for decision making without requiring advanced technical expertise. So this approach and innovation by removing or promoting self-service analytics. Data democratization refers to the ongoing process of enabling employees at all levels of an organization to access and use data in decision making process. Next technique that we are going to discuss on integration with the blockchain. So, blockchain integration refers to the process of incorporating blockchain technology into an organization's workflow, databases, or other applications. So, this integration allows businesses to leverage the unique features of a blockchain, such as maybe the small contracts and the security system, to optimize their operations and improve the data integrity. When it comes to the blockchain, we can tell about the benefits like often enhanced security. Does it? It makes it nearly impossible to alter data once recorded. There is a. It enhances the security, and also in the point of transparency and traceability. There is a all transactions on a blockchain are visible to the authorized participations, creating an audible trail. So this transparency fosters trust among the stakeholders and can be particularly beneficial in industries like finance and supply chain management. And next domain is ethics in AI and also responsible AI. So ethics in AI refers like simply it is a set of moral principles and guidelines that govern the development, deployment and use of artificial intelligence systems. So we can say like it is a multidisciplinary field aimed at maximizing the beneficial impact of AI while minimizing risk and adverse outcomes. So this involves addressing issues such as fairness, transparency. You can say more than it of accountability, privacy, and the preventing the harmless things. Next is a privacy concerns in analytics. So coming to this subtopic, we have a points over here as a data protection laws, user consent and transparency, data anonymization and masking, cyber security and data breaches, bias and ethical concerns, data ownership and control. So, well, coming to this user consent and transparency, that is collecting, processing, and sharing data only with user permission. Transparency in user consent ensures that individuals are fully aware of how the data will be processed and used. So this allows users to make an informed decision about whether they are comfortable with sharing their personal information or not. Data masking and data anonymizations are the techniques used to protect the sensitive information, ensuring compliance with privacy regulations and others. So, while both aims to secure data, they differ in their approaches and use cases. Data masking involves replacing sensitive data but with the realistic values. This ensures like original data remain protected while retaining its usability for non-production environments like testing or development. So masking maintains a referential integrity, that is making it impossible to re-identify individuals, that thus mitigating risk of misuse or breaches. Data anonymization is a broader category that removes or transforms personally identifiable information. Common techniques include tokenization, summarization, well, Anonymization of the data reduces the likelihood of re-identification. That is it may not maintain referential integrity and is less suitable for scenarios which is requiring the realistic test data. So masking normally is a specific to replacing data with realistic, ensuring that irreversibility and usability in testing environments. Anonymization is nothing but that which is encompasses various methods to remove the personally identifiable information but may lack the consistency and irreversibility of the those masking. Masking mainly used in non-production environments like development and testing. That is where realistic data is needed without exposing the sensitive information. When it comes to data anonymization, that is, it is used in the production environment or when sharing data sets externally, where complete removal of personal identifiable information is required. Next topic is managerial considerations in analytics. So normally in project management, constraints refers to the limitations or boundaries that may impact a project completions. So these limitations functions as essential guidance for the project's control, implementation and planning stages. So in this we are going to discuss about the managerial constraints in analytics. So we have a subtopics of strategic alignment, that is ensure analytics supports business goals. When it comes to the resource allocation, investing in skilled professionals, tools and infrastructure, and creating a data driven culture and overcoming employee resistance. That is those techniques we are doing in under the managerial consideration of the change management concept. So ethics and comparison is nothing but the ethics which adhere to the privacy laws, ethical standards and governance frameworks. So same as here, talent and skills development, that is upskilling employees in AI, ML, data visualization and storytelling. Vendor and technology selection, choosing the right analytics platforms, cloud providers and partners. Risk management, that is nothing but the evaluating risk of model failures, biases and over reliance on algorithms. And also measuring ROI. ROI is nothing but the return on investment. It is a performance measure used to evaluate the efficiency or profitability of an investment. That is normally it is calculated by subtracting the initial cost of an investment from its final value, and then by dividing that number by the initial cost, that is in terms of the percentage the answer will become. So that is nothing but the ROI, that is a return on investment. It is a normally used to compare the profitability of different investments and can apply to various contexts. We can say like stocks, real estate and business ventures. Same as given here, tracking the value generated from analytics investments. So on future trends, AI, real time, cloud, augmented analytics. When it comes to privacy terms, data protection, consent, anonymization, and cybersecurity. And when it comes to managerial consideration, strategy, resources, ethics, culture, and ROI. So the future trends in IoT analytics. So here, when it comes to future trends in IoT analytics, that is IoT generates huge volumes of real-time data from connected devices. Analytics is able to handle this edge analytics, AI, machine learning in IoT, and also IoT analytics of the devices which is of 5G enabled. So when it comes to the edge analytics, that is, it is processing data closer to devices for faster insights and reduced latency. As we discussed before, edge analytics is a form of data analytics that occurs directly at the source of the data generation. That is in terms of IoT devices, sensors are edge nodes. So this approach reduces latency, minimizes bandwidth usage, and enables the decision making process. So more about this edge analytics is particularly useful in scenarios where real-time insights are critical, such as in industrial automation, healthcare monitoring, and also in smart cities. It complements traditional data analytics by decentralizing processing and scaling analytics capabilities to handle the growing volume of the data generated by the edge devices. Analyzing data as it's generated can also reduce latency in the decision making process on the connected devices. Example, we can say like if the sensor from the manufacturing system detects the likely failure of a specific part, so business rules built into the analytics algorithm, which is interpreting the data at the network edge, that can automatically shut down the machine and send an alert to the plant manager so that the part can be replaced. So this can save time compared with transmitting the data to a central location for processing and analysis. So potentially like it let organizations reduce or avoid unplanned equipment downtime. Same as in AI and machine learning in IoT, that is a predictive maintenance, anomaly detection, and demand forecasting. So normally in machine learning techniques are normally in the real world applications, you can say like predictive modeling and also NLP, natural language processing, computer vision, fraud detection, and recommendation system. So when it comes to the predictive modeling, that is a machine learning, it is used to build predictive models that can help businesses to make the better decisions. So it is used to predict which customers are most likely to buy a particular product or which patients are most likely to develop a certain disease. So these those techniques are comes under this predictive modeling. So that is what given here: predictive maintenance, anomaly detection, demand forecasting. So machine learning is used to build the systems that can understand and interpret human language also. So this is important for those applications like voice recognition, chatbots, and language translation. And computer vision techniques those concepts that machine learning plays a vital role in this concept of this computer vision. It is used to build the systems that can recognize and interpret images and videos. We can say like as an application of self-driving cars, surveillance systems, and medical imaging. And also next application, like you can say, that is a fraud detection. It is used to detect like fraudulent behavior in the system in specific domains of finance, online advertisement, and also in other areas. So you can extend the application of this machine learning to build a recommendation system that suggests products, services, or content to users based on the previous past data. This is a past behavior and preferences. Integration with the blockchain, that is, it ensures security, trust, and transparency in IoT data transactions. Self-service and democratized IoT analytics. Business users empowered to derive insights from IoT data without deep technical skills. And sustainability driven analytics, that is, it optimizing energy consumption, reducing waste, which are onto the enable the smart grids and smart farming. Normally when we discuss about this integration with the blockchain technology, like it involves embedded blockchain technology into an organization's workflow, same as I said before, that databases and or those applications. So blockchain is a decentralized ledger that records transactions across multiple nodes, ensuring transparency and immutability. So by integrating this technology, companies can leverage its futures such as smart contracts, cryptography, security, and distributed data storage in order to optimize their processes. So this process is not about replacing the existing systems, but enhancing them. Example, you can say like a retailer might integrate blockchain to track products from manufacturer to shelf, that is ensuring authenticity and reducing the fraud. So the goal is to align blockchain capabilities with specific business needs. That is, it creating a finally it creates a efficient system. So privacy concerns in IoT analytics is data security risk, user consent and transparency, data ownership issues, anonymization and masking, regulatory compliance, and ethical concerns. When it comes to data security risk, smart home devices, wearables, and sensors, which is vulnerable to hacking. So normally the meaning of the vulnerable is exposed to the possibility of being attacked or harmed. So the devices which I mentioned, like smart home devices, wearables, and sensors, may be vulnerable. That is a may have some disadvantages or the those vulnerable points in order to uh, benefit on the side of the hackers, that they can might hack those devices. Next is a user consent and transparency. So, transparency in user consent ensures that individuals are fully aware of how the data will be processed and used. Users often unaware of how their IoT data is being collected and shared. So, data ownership issues like who controls the data, there is a device manufacturer, service provider, or the consumer. Anonymization and masking, we have discussed before, that is, it is necessary to protect the personal details when analyzing IoT data. And regulatory compliance, and we have the finally ethical concerns. Managerial considerations in IoT analytics. For organizations adopting IoT analytics, managers must ensure the proper strategy, governance, and execution. So we have the subtopics of strategic integration, data governance and compliance, security investments, skill development. And also technology and vendor selection, change management, ROI measurement, and risk management. The future trends are edge analytics, AI or ML, 5G, digital twins, blockchain, and sustainability. And when it comes to privacy, data security, ownership, anonymization, compilation, and ethics. And managerial consideration, the concepts we discussed before, the strategy, governance, security, skills, ROI is nothing but the return on investment. That is and finally we have the risk management. Next topic is a cloud-based business analytics. So, cloud-based business analytics, it refers to the practice of performing data analysis using cloud computing technologies. That is, it involves shifting elements of the data analytic process, like data storage, processing, and computation from on-premises systems to a public, private, or a hybrid cloud environment. So this approach enables the same organization to analyze large volumes of structured and unstructured data efficiently. Cloud based analytics solutions, it provides tools for tasks like data integration, same we discussed before, of predictive modeling, machine learning, and business intelligence. Normally, we say cloud analytics refers to the manipulation and analysis of data that happens in the cloud instead of locally in an premises business system. So, analytics system hosted in the cloud, which empowers the users to access, aggregate, analyze, and utilize their data. So, with these platforms, users can work with large data sets, identify trends for the improvement across the organization. So we also have a type of clouds like a public, private, and a hybrid. So when it comes to the public cloud, it is a normally a platform which is offered by the third party providers over the public internet. So making the space to available to everyone to who wants to use or purchase them. So it is one of the cloud computing model to make the resources where there are a lot of resources are available, including virtual machines, applications, and storages to all the end users or the remote users, we can say. The most public cloud resources that we are using in our day-to-day life, we can say, as an example of a websites, shopping apps, or or we can say the SaaS applications. SaaS applications is nothing but the software as a service application. So under this application, the handling of the email, project managements, or even our bank accounts, those finance applications or all comes under this SaaS applications. SaaS is nothing but the software as a service. So these are comes under the public cloud. So when it comes to the private cloud is a on-demand computer system that is only accessible inside your private network. So private clouds are not shared with any other organizations. So they were the clouds, which is a private cloud, while underlying IT infrastructure is dedicated to a single customers with completely isolated access. So only we can further see it as a company's intranet. Only the persons who have the authorization inside a particular organization can able to use the cloud. So hybrid is a it combines both public and private cloud. That is a communication between each distinct services. So this strategy can connect multiple computers through a network. That is a between environments and envelopes a single unified management tool. So these are the three types of clouds under this technique. So when it comes to future trends, cloud computing has transformed analytics by providing scalability, flexibility, and cost efficiency. Hybrid and multi-cloud analytics. We have a type of cloud analytics, that is a website analytics, sales analytics, financial analytics, performance analytics, and so on. So we have here some of the listed: hybrid and multi-cloud analytics, serverless and on-demand analytics, AI and machine learning integration, real-time and streaming analytics, and also self-service and democratized analytics, cross-industry cloud solutions, edge-to-cloud integration. When it comes to privacy concerns, it is of data security, risk of unauthorized access, or it may terms of in mode of vulnerable that hackers may can affect, or leaks in cloud systems. So data stored across global servers may conflict with local privacy regulations. That is a data those data type of the issues. And cloud service providers having access to sensitive business data. With this type of combinations comes under the third party risk. So next we have compilation with regulations. Again, user consent and data transparency. As we discussed before about the data and anonymization and encryption, vendor lock-in risk. And managerial considerations in cloud-based analytics. Strategic alignment, vendor selection, cost management, data governance and compilation, change management, security and risk management, talent and training, and measuring return on investment.